So there is one other thing I'm going to say, that both heat and work, put a line there. If I add all of those statements that I've given you before, I can say heat and work both are energy in transit. So here's something that I want you to know. So this is important. I think we should put it in a box. In thermodynamics, wait, hold on, pick a color.
Green.
Green. I'm going to put this in a box. It is meaningless to ask how much heat is in the system, or how much work is in a system. Rather, we can only talk about how much heat entered or left a system, and two, how much work was done on or by a system. I want you to put this in a box. Because that's important. Okay, now remind me, what was the first law of thermodynamics? Now look at both of these statements together, the one in the green and the one in the red. Look at the left-hand side. What does it have? Delta U. That is the change in internal energy. Correct? What is U? The total energy in the system. So when energy leaves the system, delta U will be negative. When energy enters the system,
Plus two plus. Sign you can just draw an arrow to it.
Is positive. Oh yeah, sorry, enters.
Energy. No, leave it.
On my left-hand side, I have two things. I have heat. Wait, pick a color, pink. No, not yellow. Yellow's a terrible color.
What's wrong with yellow? Do a dark yellow.
No one can see yellow. So following this logic, when heat enters the system, we call it plus Q. And when heat leaves the system, we call it negative Q. Okay, that one's simple. This one is kind of more subtle. So in most textbooks, you will see this written as many, many other things. Some people will put a negative sign. Guys, can you all look up? because I'm going to erase this afterwards.
What? Why would you erase anything?
No, I need to make a point. But you will see this in other textbooks where what people do is they will put either a negative sign here or a negative sign here. The way I think about it is that I think of all of these things as work done either on your system or by your system. And I'll explain how. So when the work is done on your system, then we call it plus. And when the work is done by the system, we call it negative. Okay, so this is a very good way of figuring out what's happening in thermodynamics. Also recognize that when you see a negative sign in a textbook with the first law of thermodynamics, they are calling different things. They will either call work done by the system plus or by the many different ways of doing this. This is the simplest way I have ever found on how to think about these things. And what do I mean by work done on the system? So imagine you have a balloon. You have a balloon and it's expanded to this much. What are the multiple ways of expanding the balloons more? You could physically add, you could blow into it, right? That will expand the balloon. And what's the other thing you could do? Add heat to it, right? What will happen when you add heat to it? It will expand, right? So think about that. You have expanded your balloon by adding heat to it. So you did something positive to it. Got it? That's the way I think about it. Now, how can I do work on it and it still gets hot? So think about that cylinder. Imagine if this had a piston on it. This is my pretend piston. And this is stuck in here. Oh. Okay. So this is my piston. This is where, imagine there's a stopper in here. How do I add heat to this environment? Decrease the volume. How do I decrease the volume? By pushing my piston down. That's what I'm calling work done on the system. Got it? Now, what does it mean that the work done? So, okay, what do I mean by when I say the work done by the system by that definition? Think about it. Wait, hold on. By the system would mean the piston has to go. So the system has to be expanding in order for the system to have done the work. Got it? So that is work done by the system. So going back to our definitions again, does that make sense? When you will have, so can I call the work done on the system as compressional work? Can I call work done by the system as expansion work? So do we understand what work means? Okay. So does that make sense, guys? What is work done on the system called? And what is that work done by the system called? Good. Let's write that down. So this work is going to be called compression. I think they call it compressional work. but this will be due to expansion.